Alright, so we had this done, but we need to use another machine now on a fourth axis to get this to work. So to do that, we can't just add another setup going in here because it's a different machine. We need to actually make a new file. So I'm just going to close this out, and I don't need to save it in my case because it's already been saved. And it brings me back to just my regular old part. So with this new part here, we're going to program on this. I'm going to use, if I go to my configuration tab here, I'm going to use the finished part here by double clicking it for my programming, everything I need to program it. But I'm going to use churn configuration for the stock because that's the stock I have. So I'm going to have to pull this file up kind of a couple times in my assembly. The first time to machine it using the finished one, and then the second time I'm going to pull in stock using the churned one. And you'll see how this works as we go. So I'm going to start out, I'm going to double click on finished in my configuration. This is what I want. And I'm going to go over here and I'm going to tell it I want to go to Delcam for SolidWorks, machine a part. Do you want to use the current document? Yes. And this time I'm going to use NC inch mil instead of churn. And I'm going to hit open. We need to make sure we get the Z aligned properly, which it is, which is totally fine here. But a big key is up here where it says multi-axis positioning, 3-axis milling. That needs to get changed to 4-axis milling. So we can actually do rotation. You'll see it rotates around the X, Y, or Z. X is what we're rotating around. So you see here's the X-axis, we're rotating around that. On a fourth axis on our machine that we have, well actually both machines that we have set up for it, it's going to be this way, it's going to be our orientation. So we're going to need to get the X-axis to be rotated twice around to here. We will have the Z0 be the center of our part, and the X0 be the end of our part, but we're going to have the X facing this way. So we'll have to do that once we get going. So stock axis is correct, it's up and down. I'm going to hit next. Stock body. Now this will be a little different. I don't necessarily want a bounding box. I want to use a solid body. So I'm going to change this to use solid body. And I'm going to open one. And here I'm going to open the exact same file I'm working on right now. I'm going to be using dogleg part 4. And here you'll see that I have two options. I have either finished or I have churn. Well, I want to use the churn configuration, and I'll hit open. And you'll see it overlays the churned configuration over the top of the finished one. This way we actually get it to have the stock that we already did on the CNC lathe. I'll then hit OK. Well, before I hit OK, go to material and change that to stainless. Don't want to use aluminum feeds and speeds, that would be bad. So I'll change this up to stainless, and I'll hit OK. And then I will accept this with the OK check mark. Now you'll see that it has the stock in here. My 00 is not in the correct spot. I need to create a new location. So what I'm going to do here is I'm going to tell it to create a new one. It's in the right spot for the most part. I just need to shift it over half of whatever this is. This happens to measure 370 thousandths. Now it could be 375, but I had it, when I drew this up, I drew it at 370 to give it a little clearance from when this comes down. Otherwise, sometimes it machines a flat on here. So to get this to shift over in the X distance, right here in the X, first off, I need to get this X to rotate twice. So I click on the X twice, and it rotates the X this way. And then I'm going to tell it in here under offset that in the X, I want it to offset over a negative 0.370 divided by 2. And you'll see that it moves it to the end of the part here. Now again, the part's going to be in the machine like this. So if I look at this from my front plane, it looks backwards, but notice how the X is going this way. The key is that it's at the end of the theoretical round part here, because you'll be able to edge find off of there. And I'll accept this. Now the part is set up properly to what I would actually need. At this point, we're ready to do some machining. We're going to mill these flats on here, mill this side flat, mill the other side flat. We're going to spot drill some holes, do some reaming. We're going to put this slit through here. There's quite a few things, but I do know that we need 3 pieces of geometry for doing this. We need a sketch that goes along the back here that's offset out a little ways so that it machines a little bit past on both sides. And then in here, we're going to need a back edge that we can use that's extended out approximately 1.25 inches each way so that we can actually run the slitting saw through there without crashing into anything. So I'm going to actually create all this geometry first. So I'm going to start off here. I'm going to pick this face. I'm going to go into Sketch, and I am going to create a line. And really all I need to do is kind of create a line from here straight over. I want to get it to the end point of this. What you'll see is if I bring this over, I'll get a little dashed line saying that it's at that point. And then I'm going to hit Escape. And I need this line to be offset this way a little bit. So I'm going to delete the relationship up here at this end. And then I can move this over. Now I could just drag it over, or I could actually give it a certain distance here. I could smart dimension from here to maybe be 0.250. And that will give it a little bit extra material here. So I like that sketch, so I'm going to accept it. Now I want to take the same sketch and put it on the other side. So I'm going to pick this face, I'm going to tell it to do a sketch, and then I'm going to choose this line and tell it to convert entities. And now you'll see I have a separate one on the other side, and I will hit OK. So I have 2 of my 3 sketches. The third one I'm going to do based off of here. So I'm going to pick this face. I'm going to create a line from here. I'm going to rotate a little. And I'm going to bring it over to, oh, I can just bring it out. It doesn't really matter how far. But I'll just bring it to this end. And hit Escape. Now that's linked on there. I need to get rid of these relationships. So I'll click this one, hit Delete. Click this one, hit Delete. Now I want to extend this out 1.25 inches each direction, and you'll see why later. If I don't do that, it has problems doing lead-in, lead-outs with this big slit saw. So I'm going to smart dimension this so that the end point of this to the midpoint of this over here, it's kind of hard to see what I'm doing, is 1.25. So it ended up moving the whole thing over because I didn't get this quite all the way. But if that's 1.25, the overall length then would be 2.5. So if I were to smart dimension the length of this line to be 2.5, it brings it all the way over to there. And then I just want to make sure that I have a coincident relationship between this and this back wall. So if I were to take this line here and maybe this face, let's see, that won't let me make them coincide. Maybe I could, I'm going to drag this over a little bit. If I would take this edge and shift and this line, I could then make those be, well, let's see, parallel, no, I want them to really be coincident. So maybe if I pick this point and this line, then I can make them coincide. And that'll make sure that it's linked over on that edge. See how now it's fully defined? I have this really long line that looks goofy, but you need that in order to get the machining to work properly. Now accept that sketch. So I have my 3 sketches here. So I'm going to make sure at this point I save it so that nothing really bad happens on me. So I'm going to save, yep, save all. Save it as the assembly. I don't want to override assembly 4 because that was the churning portion of it. So what I'm going to do here is I'm going to call it dogleg part 4/1 or something else, so you know that this is actually going to be the milled portion of it. You could call it 4th axis or something like that. I'm just going to call it 4/1 and I'm going to hit save. Now we're ready to actually do some of the machining. I'm going to go over to the Delcam tab, and I'm going to do a new feature. Now these two flats on here, you could think of them as faces and whatever, but really what you're doing is you're using a side feature. I'm going to use this line and tell it I'm milling the side of it. So I'm going to go down here to the side, and I'm going to hit OK. And I'm going to do two of them back to back. But I'm not going to pin this open because I need to make sure something gets turned off later. And actually I'll turn it off now. I'm going to hit the red X here to cancel out of this. When I go into new feature, I want to make sure that add setup for new features when needed is not checked. Because if that is checked, it will try to make a setup thinking you're going to stop the machine and flip the part over. And it won't make the A axis of the rotary rotate to machine the other side. So that needs to be unchecked. So I'll hit OK again. Now I can pin this open because I want to make two different side features. I'll pin it open. My boundary is going to be this line. My bottom is going to be this face. And my top, if I check top here, is going to be this stock. So I just pick anywhere on the stock. And you'll see what happens is it figures out the vertex up at the top of that. The yellow is coming in the direction it's actually going to machine in. And this is saying what side the material is going to be removed from. So if I were to leave it this way, it would machine all this away. That's bad. So I want to click on this to go to the other side. So now it's going to come in like that. And I'm going to hit OK. Now the other side, it's asking me right away to choose. I pick this line. My bottom, if I rotate this over, is going to be this. And my top, again, is going to be my stock here. See how, because I created that sketch from that face, it knows to come in this way. This time it actually created my cut side correctly, and I will hit OK. Now I'm going to hit the red X, and look at what it gives me. Now it usually defaults to the biggest tool it can possibly use, which is way too big. So if I were to play this, you'll see it comes in with some huge shell mill that it's going to try to mill with. Not really what I want. So I'm going to stop the simulation here. And I'm going to go in, I'm going to use a 1/2 inch end mill. We use a roughing style when we're out at the machine. So I'm going to go here to DFS features, and I'll see my side here, rough and finish. So I'm going to double click on rough 1, and I'm going to go here to where it says the 2-inch end mill, double click, and I'm going to change this to a 1/2 inch end mill. And I want to make sure I'm getting a 4 flute. So if I go down here, I'll see a 1/2 inch 4 flute. You don't want the one that's got anything special on it, or you just want the 4 flute regular. And we'll hit OK. Feeds and speeds, it thinks it's a high-speed steel, so it's using 134 RPM, 1 inch a minute. We could always go into this and look at it and say, well, I want to use a surface footage or something like that. So if I say use surface footage, it's using 70 surface feet, which is not that bad. It's actually pretty good. And then down here for feet, you can tell it to use inches per minute, or you could tell it to use inches per tooth, and you could tell it what kind of chip load you want to use. And here it's 3.8, almost 4 thousandths. That's probably fine for roughing. We'll hit OK. Some of the other stuff it's using flood coolant, my step overs. What I'm looking for here is finish allowance. It's going to leave 15. Doesn't really matter because we're going to turn finishing off. Rough pass Z increment will be defaulted to a certain percentage of the tool. I think we're okay for now. So I'm going to accept this. I'm going to turn the finish off. And then I'm going to play it. Now remember, this is doing the second side. So it did the one side correctly, the other side incorrectly. Stop it. I'll go into the first side. I'll uncheck finish. Double click rough pass 1. Same thing here. I could double click the tool. Because I've already used the 1/2 inch, I can check this box that says recent tools and grab this 1/2 inch and accept it. And then my feeds and speeds, again, I could come in here and I could tell it to use surface footage and tell it to use inches per tooth and hit OK. Accept it. Now if I step through my simulation, now you'll see that it's using the smaller tool. It does the one side, and then it does the other side. Rotates the part over, does the other side, machines it off. So we got our flats milled on there pretty nicely. I like that. Now we need to do some spotting. Get a couple hole spots. You'll see the Z is pointed up here. We could drill all the way through with this drill. I think what I'm going to do is probably do this hole first. This is a 126 reamed hole. So I'll do a new feature. This was drawn, however, as just a circle cut through. It wasn't drawn as a hole wizard hole. So we have to do this as a hole and not a feature. So I'll choose hole and hit OK. Plain hole through. The diameter, I'm going to pick this cylinder. It gives me the diameter. It shows that it's coming from this direction. It's not really a big deal. You can just rotate the part over and do that. But if you did want, you could re-choose the top and bottom and choose this as the top, that is the bottom, and then it would flip it. I really don't care. I'll just have it rotate over and do it. So I'll hit OK. And you'll see it made hole 1. It spot drilled it, and it drilled it. The drilling will be set up to try to get a 126 drill, but I want to try to undersize drill it and then ream it. So if I double click on hole 1, I'll see a spot in there that says ream, no. So I'll double click that to say yes, and now it'll try to ream it and it'll adjust the drill accordingly. If I take hole 1 here and right click and go to preview, I can just watch what this one does. So if I step it, grabs a spot drill, and I could always change this to a center drill or whatever you'd want to use. Spots it. See here, no problem. Step it again, changes tools, grabs a drill, drills it, and it'll peck through because it knows that it's a small enough drill, it can't do it, pecks through. And then it will grab the reamer, and it'll ream through. One thing I have noticed with DFS is that the reamer seems to go too fast many times. So I'd like to check the reamer feeds and speeds. Here you'll see, if I go in here, it's using 1037 or 1137, 4.3 inches a minute. This is stainless. I'm a little leery on that. Maybe I kick this down to 2 inches a minute. Maybe I only use about 800 RPM. But just be careful with it. I did notice on some of the A2 stuff we did earlier that it went way too fast. So hit OK. Now if I simulate through here, you'll see that it puts the hole through, reams it. I'll stop it. I have a few more things to do. This hole here, I can tell it to do this hole. And this was done with the hole wizard, and so was the lower one. So I'm going to do a new feature. I'm going to do a feature. Hit OK. And I can just choose this hole anywhere on it. And it will look at it and say, hey, I'm going to go, and I'm going to do this as a spot-faced hole this deep. But I want it to really come down to about here. So if I said bottom and chose this face, you'll see the drill will come down to there. A little more than I want, but I would like it to come down and actually spot into that bottom portion for the next drill. And maybe leave a little chamfer on there. So I could tell it here to say go on 0.01. It goes deeper, so I can tell it negative 0.01. It goes a little shallower. You'll see there it looks like it's going to chamfer that off a tiny bit. And I hit OK. So here it spots it, drills it, counterboards it. Simulate. Let's see, it's doing it there. Everything looks fine. So stop again. Now I want to drill this through for a tapped hole. We are going to tap this, however, by hand. So I don't want it to spot it, drill it, and tap it. But it's just easiest to program it as though it's going to do that and then uncheck the ones I don't want. So I'm going to do a new feature, and hit OK. And my feature will be that hole. You'll see it's trying to come in, and it's only trying to tap so far and all that. I'm not too worried about any of that because I'm going to churn most of it off. I would like maybe for it to go a little deeper, so we can adjust that a little later. It's like the bottom here, I could say 0.05, and it goes a little bit deeper, 50 thousandths deeper. We'll hit OK. And I'm going to turn off on this one the spot drill because I don't want to spot it. I just want to drill it. I'm going to turn off the tap. So now, even though it looks like it's got the whole thing, if I were to simulate it, it's just going to drill it. So if I take this hole and I preview it, you'll see that it comes in here and it just brings in a drill. It'll come down and it will drill through the part from the side that it had previously been drilled on. The last portion we have to do here is a slit saw. I made this line plenty long enough so that it won't come in and crash. This one here, it's kind of weird the way it gets done. It's going to be done as a groove feature. And you'll see my line is up here at the top, which is really the bottom, because this would be flipped over the way the Z is pointed. Just keep that in mind. So I'm going to do a new feature, and this is a groove. It just happens to be a side groove. I'm going to do it as a groove. I'm going to hit OK. And in here I change this from simple engraving or whatever it ends up being to side groove. And my boundary will be this line. And you see how it kind of gives us some stuff here. I've done this earlier, so some of my numbers are already previously populated here. It says curve at bottom, yes. But what it does is it mid-planes it, it splits it. So what I want to do is tell it my width is an 1/8 inch. Now the width is thinking the groove width, like that. So I make that point 125. And my depth is how far it's going from here to here. So I ended up figuring that out as about 425 worked. And I'm going to take my top. So I'm going to click in here for top. And I'm going to tell it that my top of this is up here. And give it an offset of negative 0.06 to actually 0.063. So what that will do, actually, let's make it negative 0.0625. That should center that in there. So the numbers in here are 1/8 inch, 425, pick face of the top portion of it, and then give it a negative 1/16. This is an 1/8 inch wide groove. And we'll hit OK. Now if I look here, it put this out of order. So if I'd go over to my ops list, I'd see that it's trying to do these two sides first, which is good, and then it's trying to groove it. That's probably fine, but I really want to groove it at the end, so I don't get it to burr up when it's drilling these holes. So I'm going to take these two grooves, and I'm going to move them down to the bottom. So to look at this, we'll get this and do a little verification. First off, I'm going to verify some of it, and then save that location, and then just come in with the last one. So I'm going to go here to my part tree, and I'm going to uncheck groove 1, and I'm going to simulate all this. So I'm just going to do a quick simulation. Comes in, does everything. It's a wonderful thing, and I'm going to then save that. So I go in here and I say save simulation results. Oh, nope, that would save an STL. I'm just going to go here and say set starting point. Alright, now I can uncheck all the ones I simulated there. Just check on groove 1. And then when I go in here and step this one, you'll see my tool, this big slit saw up here. Rotate this around a little. Computer's a little laggy. And I'm going to step this over. See it come down. Now it looks like it's way off the part, but the problem is with the lead in, lead outs as we get going, it ends up almost hitting later. So if I look at this and I go to, let's say, top view. Let's look at this in the top and play it. It's pretty fast. See, it's way out here. It comes through and it's big lead. It's kind of going back and forth. It only took 2 steps into it. That's not a very good thing. So I need to make some modifications, and when I modify it, it ends up screwing some stuff up that I need to use that longer line with. So I'll stop this. I'm going to go into the groove rough pass 1. And what I want to do now is I want to change my step overs. So if I go into step overs, you'll see it's going 410 deep in one pass. Not a good thing. So we're going to change this to 0.125. And when I do that, I'll show you how it messes things up a little bit. So I'm going to go in here. Now I'm putting this in top view. I guess it would be, yeah, we'll put it in top. And now when you watch this, if I simulate it, well, it still looks okay. And I think it's because we got the line longer. If I had that line short, it would end up hitting. So I'm going to stop it here. I want to go in and get rid of the back and forth feeds. So I'm going to go into rough pass 1 and under step overs, I'm going to turn off my leads. Okay. Hit OK here. Turn off my finish. The finish should be okay, but in finish I want to get rid of my leads as well. And then in the actual groove 1, and here I want to turn off bidirectional rough. So I double click bidirectional rough so that it won't be going back and forth. So that slit saw, you really just want to go one direction. And I hit OK. So now if I step it, feeds across. Now it looks like it's quite a bit, but once it gets in there further, it needs to be that far. It's taking these 1/8 inch steps. So see how it's barely off of it now? I lift up, come back. So maybe we could go a little less than what we did, but not too much. And then it goes back to the center. You see it slip that out. So those are your steps for getting this portion done. After this, we have to do some other stuff. One thing is we have to throw it into a lathe again and do a part off tool through here. And then after that, we'd set it in a mill in between here and do the milling on the back side of it. So that's it for this video.